Welcome back to Bal Vigyan Bharti. Now, in this coming episode, we will discuss some proof on arithmetic progression in the form of sum. So, that may come if it is being given directly with an example, or in general, you might have to prove that this also holds good when we are talking about an AP. Okay, so the first of this kind is coming as prove if a number is added or subtracted to each term of a given AP, then the resultant sequence is also an AP. Understood? So that means I will show you one after one the two cases. The case one where we will add any number, any natural number, or any number, means that could be a integer, fraction, anything. If we add all means the same term with all the terms of an AP, then the series what we will get will remain as an AP. Okay, so let me take as an example that an AP in general, for a better understanding, we can represent it with the terms, first term and the common difference. So we are taking is a plus d, where a is the first term and d is your common difference. So the term will go like this. Okay, so this is the actual AP we are talking about, the AP. Now, as per the condition, we'll add any number. Let's say, assume we are adding a number which could be a fraction or an integer or anything. Let's say be t. Let's say small t we are adding. So the term, if I add t to all the terms, so this will become a plus t, a plus d plus t, a plus 2d plus t. Like that it will happen, because I am adding the t as per the condition with all the terms of the given AP. So the first term was a. If I add t, it will be a plus t. Second term, as usual, if it is d is been taken as common difference, so a plus d, with that I will add t, so it will be a plus d plus t. Similarly, the third term will be a plus 2d plus t, like that. Now we have to prove that the series I have got is an AP. So how will I prove that my only the instrument, or by the definition we know AP, if all the consecutive terms, the difference of all the consecutive terms are same. So if I can prove the second term of the new series, if I deduct the first term from the second term, whatever result I will get, the same result I should have when I deduct third term, second term from the third term. So that means the term second minus term first of the new series has to be equal to term third minus term second. So if I can prove it, then we definitely can say that the terms in the series is an AP. Okay, so for doing that, this is, if I go with the left hand side, so left hand side says term second minus term first. So term second is your a plus d plus t in the new series, minus term first is equal to a plus t. Now calculating this, removing the bracket, I will get this one. So here you can see that t is not a part when we deduct any term from its previous term. T is in the virtue of the calculation, it is nullified. So definitely the result I will get by calculating all this as D. So one more thing you can understand, if any terms added to the actual AP series, not only I will get now, just let me do the right hand side also so that it will be more clear to you. So 2D plus T, the third term, minus A plus D plus T. Now similar way, if I remove the bracket, I will see the result again also I am getting D. So what I am going to say, not only if I add anything to the original AP series, I can prove that the new series is an AP, because the difference I am getting deducting two consecutive terms is same. At the same time, the common difference that I am getting, if you see clearly, this is same as to the actual series. So that means we can extend it in such a way that any term added to all the terms of an AP, not only it will remain as an AP if I talk about the new series, but the common difference of that series which I found by adding the terms have the same value as the common difference of the actual AP series given. Understood? So similar way, if I fetch one series, instead of adding, if I do subtracting, means if I put it like that, we are adding or subtracting. So the same thing I can take. Okay, if I do the subtraction of T from the terms, the series will become, instead of A plus T, it will be A minus T, and then A plus D minus T, then A plus 2D minus T. Likewise it will progress. And if I calculate the similar way, the second term minus the first term, I will get A minus T, A plus D minus T, minus of A minus T. Now if I remove it, if we talk about the second term minus first term, where this will become A plus D minus T minus A plus T. Now here also you can see the T is not contributing anything while we are calculating the common difference. So ultimately I am getting D. If I do the same thing with the third term minus second term, let me check what I am getting. I will not get any difference. Okay, but still I am showing you by calculating it. It is very easy calculation, anybody can understand easily. Now here also, if we see, I am getting D as an answer. So either I add the term or subtract the term, I will get definite an AP series, and at the same time the common difference I will get will be the same as the common difference of the actual series given. Okay. Okay. Now I will move to the next problem. I hope you can see it, but still I am reading it for you. Prove if each term of an AP multiplied or divided. Now instead of adding or subtracting, this is the second one is saying if we multiply or divide all the term of an AP by a certain number except 0. There is a condition, it is differing from the earlier one, but earlier one, if you add 0 to the term, it won't change the term. So there is no certain reason to say when we adding or subtracting and we eliminate 0, because everybody knows that 0, whether you add or subtract, it won't change the term. So there is no need of saying 0. But whereas if we don't eliminate the concept of multiplying or dividing 0, it would take you some other way, or it would wholly change the concept of the requirement. Okay, so it has to be such that you need to mention that 0 is not a part of it when you are trying the same thing by multiplying or dividing with a certain term. Okay, so prove if each term of an AP multiplied or divided by a certain number except 0, then resulting sequence is also an AP. So again we'll go one by one. First we'll talk about the multiplication. Let the number with which we are multiplying is t again. I am taking the t again. So, and the series B, the original series I am talking about, series B, a plus d, a plus 2d, likewise. Now, when we multiply this, the new series will become a into t, at, a plus d into t, a plus 2d into t, like that. Now my way of means proving that this new series would also represent an AP when I can get the difference between the two consecutive terms is same. So the same way, the t2 minus t1, if I do, it is a plus d into t minus a into t. Calculating this, removing the bracket, I have to multiply t with both the terms inside the bracket, and then I have to subtract the second term. So from there I will get d into t as a result. Now same thing I will do by doing t3 minus t2, the second consecutive terms, and let me check the result is holding good or not. So this will become into t, removing both the brackets, I will get minus d into t. Now if we nullify all the common terms and the terms in between calculating, we will get definitely dt as a result. Now you see the common difference in this case, by the common difference both case between the terms is same. By that we can say the new series is an AP, but the common difference is not same as the original common difference of the given series. Okay, so there is a difference between the thing. So now here you can see the common difference I am getting, the common difference of the actual series into the number multiplied. So there is a rule for that. The series that I will get as a common difference of the actual series into the number multiplied with that. Now the same if I trying to do for the case of, this is your case 1, for case 2 the same thing I will do for division. So and I will take the number that I will do with is t again. So my term will become the new series a by t, a plus d by t, a plus 2d by t, plus dot all this. So again doing t2 minus t1, I will get a plus d by t minus a by t. So you can see the t be the LCM between these two fractions. So a plus d minus a will be the result, and you will get definitely a by d by t. Doing the same thing with the next consecutive terms, a plus 2d by t minus a plus d by t. This time also you will get same your same LCM. Okay, so LCM is getting t. Now this will become 2d minus a minus d. By calculating you will get t. So this case also you can see the common difference I am getting for the consecutive terms is same, but this is not the same as the common difference. So by that you can say that by dividing also with the term, you will get a series which will represent an AP. But the common difference in this case, you can formulate it by common difference of the actual series by the number divided. Okay, so in case of multiplication you have to multiply with the number, in case of division you have to divide by the number. Okay, so this may be another rule. So in case of subtraction or addition, you will get the common difference same as the actual series. In case of multiplication, you will get the common difference by multiplying with the number. You will get for division, you will get the common difference by dividing with the number. So this is the only rule, but in all cases your new series will be an AP. Understood? So I will end up here. In the next video I will move on to the problem number 16, which is another proof. Thank you.